Alright, welcome. Just a quick teaser. By the end of this tutorial, we're going to be making a shader that has this repeating pattern moving. Alright, welcome everyone. So in the last shader tutorial, we kind of looked at these two variables, color and UVs, and we figured out that you could manipulate the color based on its position, and the pixels will sort of create these gradients. Now I want to show you these things called uniforms, and uniforms are basically just variables that we declare here, and they act a lot like export variables in GD script, and it'll allow us to manipulate the values over time. So we're going to take one step back, and we'll go back to solid colors for a minute, just to show you how we can sort of manipulate some of these things over outside of the shader. So let's just come here, and if we go back to 0.0 now, we'll recall that all of the colors being 0 will be black, and of course the opacity is 1, so it's solid black. So now there's these variables called uniforms, and if we come back and just make sure we see our shader material over here, you see there's not really much going on over here, but let's add a new variable called uniform, and we'll declare it of type float, and we'll call it red for the red channel, and we'll set it equal to 1. And now, all of a sudden, over here, we should see this new thing called shader parameters, and you can see it's got a value of red. And sorry, I think I was manipulating things before, so it already had a default, but you can see that right now its default parameter is set to 1. So just like in an export variable, we can change this and manipulate it. But first we need to actually use this variable. So we're going to set our red channel to this red float value. And all of a sudden it turns red because, you know, red is 1.0. Okay, you get that. So here, if we come over here, we can now kind of change this parameter. And we can set it to, for instance, 0.5, and now it'll be darker red. And we can set it to 0.2, and it'll be darker red still. Now, of course, you know, we have to type in all the values. Maybe we want something a little bit nicer than that, and we can actually add a slider to here, and we do that with a little bit of a hint here. So there is a little bit of additional magic that Godot has added to make our lives easier. So if we come here and we add a colon after the red, and we type hint range, and fortunately the autocomplete will pop up, you can see that now if we look over here at our shader parameter, there's a little slider on our hint range, and we can now just kind of manipulate it more easily. And if you want that to be even more precise, we can just change the unit of the range, so it'll go between 0.0 and 1.0, and now the slider will move by increments of 0.01, and you can see we can now manipulate it more precisely. So let's go ahead and do that for all the other values and set these uniforms so we can manipulate them outside. And we'll work smarter, not harder, so let's just add some multiple cursors. And I need green, blue, and alpha, so uniform, float, we'll leave that blank for a second, hint range, we're not getting autocomplete, but oh well. 0.0 to 1.0 with a slider of 0.01 equals 1.0 to start. And now, we don't have any variable names, so we'll add green, blue, and alpha. And now we have to use them, so we'll put them down here, but green and blue and alpha, and it should, if everything works, turn white. But it doesn't turn white because, remember, we've actually manipulated our shader parameters, and that's, again, I'd already had some previous values, and I guess the editor saved them. But if we return these to the default parameters, they'll all be 1, and then we can change them as we see fit and make it maybe a little more transparent. All right. How do we actually manipulate these things in code? And I'll show you some cool things we can do with that. So the first thing we need to do is we need to get access to the material in code. And as you can see here, if we hover over it, remember every canvas item has a material. Even if we come to our world, which is a node 2D, and we hover over here, you'll see there is a material property. It's empty right now, but that's okay. So let us make a script. And we'll just make a script on the color rectangle. And you could do it on the world too if you wanted to and just get the parameter that way, but let's just do it on the color rectangle. So the color rectangle, just maybe I'll leave ready. Let's up here, Control X that, Control X that, and we'll just get rid of that. So we need access to our material, and remember we're a color rectangle which inherits from the canvas item 2D, so we already have access to that material property. The problem is, if we come back to our material, the material can actually be one of two different things. It could be a canvas item material or a shader material. And because of that, Godot just will default to generic material, and the problem with that is that we won't get the shader material specifics if we try and do autocomplete. So let's make sure our autocomplete works. So we'll make an onReady variable, and we'll call it shader material, and we'll make it of type shader material, and we'll set it equal to, and you want it to be material, but remember this object hasn't been made yet. So, but we are going to wait for it to become made. That's hence the use of the onReady variable. So we can do self dot, and then now you'll see the shader material pop up. So now we've taken our shader material and we've stuffed it into this shader material onReady. Oh no, what am I doing? Self dot material. Okay, sorry. The self dot shader material was this variable, but the material is going to be stuffed into this shader material variable we made. And if we come down here, now autocomplete can be a little bit dicey, but if we come here to our shader material and hit dot, fortunately we are getting the autocomplete to pop up this time, but if you're ever having an issue, you can always import the material as shader material, and that might fix it as well. So we'll just leave it like that, just for reference. So as you can see, when we hit dot shader material dot, we'll see these two variables, get shader parameter and set shader parameter. And we are interested in changing our shader parameter. And let's just start out with the red to start with. So we will go, you send it the string name of the shader parameter. So that's the one little other thing you have to realize. We called it red. And if you look in the shader parameter, you'll see the actual name of it, and that's underscore red rather than capital red, even though the inspector shows it capital. So we'll do red, and the value, let's set the red to 1. And I almost put a semicolon for no good reason, because remember now we're back in GDScript, so you don't need semicolons. And let's run it, and let's see what happens. So right now, if we look at our material, it looks like this vomity green color, but let's hit play, and now we have this nice sort of lighter orange color, and that's because we set the red channel to 1. And just to prove that to you more so, we can come back to our script, and we can set our other shader parameters. So let's copy this, and we'll do green, and we'll make that 0, and let's say we want a nice maroon color. We'll set our blue to also be 1, and we'll set our alpha to a solid color. So remember, before it was transparent, so if we come back, we'll still see that is this vomity green color, but if we hit play, we now are coming back to our maroon. So great, we now have connected our code to our shader, and we can manipulate the shader with code. So let's just do one fun thing. Let's add an animation player. And we'll take our animation player, and we'll make a new script, and we'll call it, a new animation, we'll just call it All right. And we can look at our track, and if we come back over to our color rect, we now can see that we've got all our little keys on our shader parameters. So let's go ahead and make a shader that changes colors. And let's make this over 5 seconds. And we'll take our red color and we'll set the value. Let's start off with no red, and then we'll move to all red. And just make sure that our parameter is continuous. That way it'll interpolate the values, and we can clamp to make sure it doesn't do anything, and we'll hit play. And what's happening? Oh, right, because we haven't auto-started our animation. So let's auto-start it, and let's hit play. And are you still not working? Why are you not working? All right, let's see if we can figure out why you're not working. Let's see, animation player, color rect. Oh, what happened here? Oh, I don't have another value. That's why. So let's just come here, we'll duplicate that value, and now we have, to start out with, we'll have a value of the material shader parameter red, and we'll start that out on this part at 0, and then we'll come here to our last node and make that 1, and we'll set that to continuous, and we'll claim, okay, so this should work. Let's actually just try and hit play here, and you can see that over time our shader parameter is being edited to change the color. And just for funsies, let's animate some of the other ones. So we'll just come back to our color rect, and okay, so I don't know why it does this. Sometimes the key values disappear from this, and it makes it very frustrating. All right, let's see. What if we add another track, property track, color rect, and if we do material, no, see, that's not the parameter though. Shoot. I don't know why our keys disappeared. What if we make a new animation? Something else? Okay. Our keys disappeared. Arg. So I think this must be a bug in Godot. I don't know why our keys suddenly disappeared. Let's just come here and we'll do this, and we'll delete this. Let's see if we click here on our color rect. Oh, and then it's back. All right, I don't know why. I don't know why this does this. So you can come here, and I guess you can animate all of these at once. Just grab your keys. I don't know why the keys disappear. It must be a bug. So hopefully they fix that. All right. But here we now have a bunch of different values, and since unfortunately we can come back to our first thing, and we'll just key different values. So we'll start out with a green of this, and a red of this, and an alpha of, let's make it kind of transparent, and let's hit, and what do we do here? This is our red parameter, so let's just key that at this, and now let's just hit come back to our 2D scene. We'll hit play, and you can see over time this changes colors to whatever we had set it at the end. All right, great. So we can now animate our thing. Just, I guess you might have to struggle with that a little bit, but we can animate them too. All right, let us now go back to shading, and we're going to learn a new concept this time. So we now know we can manipulate these over time, but we can actually do that in code as well through our, so let's just delete this so we don't end up with a lot of bizarre behavior. So I'm just going to remove all this, or let's just hit Control K to comment all this. So now we should just be dealing with our shader again. So let's come to our shader and look at our 2D scene, and we'll hit play, and hopefully nothing weird happens. Okay, good. So it's just whatever we see on the screen. And we can reset these values so that we're not overriding our uniforms in sum. All right, so now we've got back to a boring old white rectangle. So the next thing we want to kind of look at is something called sign. So I think, as you probably are aware from hopefully you've taken a little bit of trigonometry, but we do have this function called sign. And what's really nice about sign, if we just take a look at it, kind of zoom in here, sign is really this great function because if you look at it, no matter what x you put in, it'll go on infinitely. So no matter what value you put into the x value here, you'll get this repeating pattern. And as you go up, you'll kind of traverse this sine wave between positive values and negative values. And what's really convenient is that with the unit circle, you can, the values that will be returned from the sine function will go between 0 and a maximum of 1. And if you think about it, that's great because what do our colors go between? 0 and 1. And remember, all our UVs go between 0 and 1. And so this is going to be really convenient to set up periodic behavior. So let's come here, and instead of just passing in red, let's take the sine of red. And sine is a built-in function into the shader language. Your graphics card actually hardware accelerates these functions, so you get really fast calculation of sine. Now, of course, this isn't going to do much, because if we're just taking the sine of, what are we, taking the sine of 1, all we're doing is just getting a value back. And so if we look at what the value of sine of 1 is, it's 0.84. So right now we just have a slightly off-white, slightly bluish colored value. But we want to kind of change this over time. And fortunately, Godot makes this easy with this variable called time. And I actually don't know what, so unfortunately we don't have documentation here, so let's just see what value time is. Let's see, is it var, no, let's see, int time equals time, let's see, does that, okay, so no, so time is definitely a float, which is great, because we need to pass in a float to our function. Let us just put in, instead of sine red, let's put in sine time, and now let's see what happens. And all of a sudden you can see the color kind of changing from cyan to white, although it stays cyan for a while, and then we'll come back to why that is in just 1 second. But let's just, for the sake of making life easy, let's set our green and blues to 0. And now when we've set our greens and blues to 0, we can see that over time, as time goes on in our program, the sine function is returning bigger and bigger values of red up until a maximum of 1. Now, why is it dark for so long? You can probably imagine why it's dark for so long. If we come back to our sine function, we see that, and let's zoom out a little bit, we see that before it starts to repeat again, the full sine wave goes between 0 and 1, but then it comes down back to 0, and then it's just negative. And remember, negative colors in our color function, in our color vector, are just going to be black. So this whole time is black. So basically, for half of the sine wave is black, and then honestly, for even probably part of it, this part of the positive, it's still pretty dark. So it's going to be dark for at least up to here, and then you'll start to see a lot of red, and then it'll come back here and it'll just be dark for this whole time. So let's see, how can we make it so that we're not dealing with this whole part of the sine wave that's negative? And you're probably screaming at me, absolute value, and you are correct. So we can take the absolute value of the sine function, and let's just see what this does. All of a sudden, by taking the absolute value, we have now said that if you are in the positives, great, but if you're in negative, just flip it to positive, and now we'll see these humps, and now all of a sudden it's only going to be dark for a fraction of a second or a fraction of the time, because just about here will it be 0. So obviously you will now start to see, if we take the absolute value, and fortunately there's an absolute value function, we can just do abs time. Now all of a sudden, if we save it, you'll see it's just dark for a very short period of time compared to before. So now we're starting to see that we can use time and use some periodicity, and we can manipulate. We can manipulate the variables. Let's say we want to make this. Let's say we want to make this a lot faster. How can we do that? Well, if we think about it, what happens if we multiply time by some value? Let's say 2. Now all of a sudden it's going a lot faster. And remember, why is that? Because now you're basically just traversing this function faster. You're going to crunch it together. And so let's have a look at that. So if we take, let's just start off with the basics. Let's get rid of the absolute value, and we'll just do sine x. So if we look at our sine x value, and let's just multiply the sine x by 2, what is that going to do? This will change the amplitude. This will make it 2 times bigger. So if we hit enter, now all of a sudden it's 2 times bigger. But remember, we don't really need the amplitude of the sine function to be 2 times bigger, because basically it's going to truncate here. So we're just going to look at it. It's going to come up to from dark to 0, and then it's just going to stay 1 this whole time, the value of red, and then it'll come down. But you can use that to sort of create a little mountain if you prefer. So it stays, red for a solid red for a longer period of time. But let's actually see what happens when we multiply x by 2. And now all of a sudden, when we hit enter, you can see we're still getting the same amplitude of 1, but we've now crunched the sine function a little bit. And if we just kind of keep doing that, you can see it's getting closer and closer together. And I think it's manipulating the axis, so you're not seeing that quite as much. But let's just have it so that we're looking between 0 and 6. And now when we go to 1, you can see that it's quite spread apart. 2, it gets narrower. 3, it gets even narrower. Let's do 10, and you can see it's really going to increase its frequency. So again, if we take the absolute value of this, now you'll see that it's just bumping in this x direction. So let's just have a look at this. Let's do 10, and you can see, it's really flashing like a little siren. If we get rid of the absolute value, you might actually like this aesthetically. I have one too many parentheses, and it's going to complain. But now it's going to be a little bit less. So great. So now we've learned about time. And as you can imagine, we can start to manipulate the position. So let's have a look. Okay, let's stop here. Okay, this is going to cause the seizures. So let's just stop this here. Let's just put this back to red. All right. So where do we go from here? We now know that we can kind of manipulate these things with time. Let's go back to looking at the UVs. All right. So in order to just make things easier, and if you're following along in the book of shaders, you probably got to that part where you could see those graphs, and unfortunately I think the part that makes it confusing is when he adds the green line. And while it's clever to show the green line, I think it makes the code really confusing. So let's just look at some gradients for a little bit, and then use the sine function with regards to the gradients. So let's just play around with one specific color for now so we don't confuse ourselves. So let's just look at red. Or actually, let's do blue. I'm sick of red. So we're just going to set greens to everything, and we'll just make it a solid color. All right, and I think we unfortunately set blue to 0 in our inspector, so let's just come back here and come back to, oh, green. I don't know what I'm doing. All right, so we've now come back to a solid blue color. All right, and we know that we can manipulate the solid blue color with uv.x. Now, let's just set a value called gradient. Let's make a variable called gradient. And it'll be a float. And we'll set it to uv.x. So we really haven't done anything other than this is exactly the same as just sticking uvx right here in gradient. But let's start to do some functions on the gradient, and let's see if we can manipulate this a little bit. So come here to gradient, and let us see. I want to flip this gradient around. So right now, if we think about gradients, we can actually recall that when we're making lines, probably remember from math, y equals mx plus b, right? That's the slope of a line. So what happens if we assume that the gradient is the same as our y here, but I'm going to use gradient so that we don't confuse ourselves with the uvy's and all that. But let's just pretend that the gradient is basically the same as y. So we're going to be making a line. So if gradient is the y, then what happens if I start to change the slope of this line? And remember, m is the slope and b is the intercept. So let's just see what happens to our gradients. So let's multiply this by 2. Let's see what happens. Oop. Oh, right. Got me. So remember, you can't multiply by. So now all of a sudden you can see that our gradient has gotten crunched a little bit. And what's happening here? So if we think about it and we think about our UV, oop, that was not what I want. And we think about our UVs, so we know that this pixel here, so going back to our thing, this pixel here has a UVX of, wait for it, 0, right? 0.0. And of course this is, in the y direction is 0.5, but we're not concerning ourselves with the y direction now. We're just making a linear gradient across the way. And this value here is a UV of x is 0.5, right? It's halfway through. And then this value here is going to be 1.0 in the x direction. So let's look at what's happening with this gradient function here. Ooh, where did my pen go? All right. So if we look at the gradient, we're saying that it's now 2 times the x value of the UV. So what's happening? If our UV is 0.5, so if we're this pixel right here, where it's 0.5, I'm saying the gradient value is going to equal 1.0, right? 2 times 0.5 equals 1. And we know that we're stuffing this 1 into the blue value. So if we're stuffing 1 into the blue value, halfway through, anything over this, like if we're 0.6 or 0.7 in the x direction along the way, if our UV of this pixel is 7, or 0.7, excuse me, we're already times 2 is 1.4. And remember, values of blue can't go over 1.0, so it just gets truncated back to 1. So we're essentially crunching the gradient down, and we're sort of seeing this increase. We're seeing this much more rapid increase in our values. All right, so that will lead to the loss of the gradient. Once we hit the halfway point, all our values will be lost. And similarly, we can actually stretch it out. So let's come back here, and let's, instead of multiplying by 2, let's come back to 0.5, and we'll essentially be dividing by 2. And now all of a sudden, the gradient gets darker. And what we've done is really, we've stretched the gradient out. the gradient now kind of goes all the way over here. Sorry, this is a little bit more than 2. But if we think about it, let's just think about our function again. So we're just looking at x values. So pixel here is going to have the same x value as the pixel here, and this one will have the same here. These will all be x's of 0.5, and this will all be x's of 0.0, and this will be all x's of 1.0. So if we now look at our gradient function, what's happened? Where did my pointer go? All right. Now, if we are an x of 0, well, what is gradient going to equal? Well, gradient will equal 0, because 0 times 0.5 is 0. So our color blue will be 0 anywhere where our x values are 0. But let's get up to 0.5. So where we were before, we were at 0.5. If our x value is 0.5, well, now no longer are we at 1, or when we hit 0.5, like we were when we multiplied by 2, but we're actually at, what's 0.5 times 0.5 is 0.25, so we're actually only a quarter of the way along our gradient. And so we've made this darker, and then finally if we hit our UV value of 1, the color of the pixel, right, the color of this pixel right here, or this pixel right here, or this pixel right here, is going to equal, because the UV of theirs is set to 1, it's going to equal 0.5. So that's why our color blue is never going to get higher than a maximum of 0.5. So we've sort of stretched our gradient out. Now what happens if we try to change the slope of the line? What if we add a value to it? Let's go back to our normal gradient. And remember, our normal gradient is just 1, so if we're at 0, our x is 0. If we're at 1, our blue is going to be 1. But what happens if we add a value? Well, if we add 1 to everything, hopefully you can guess what's going to happen. And if you guessed it's going to turn solid blue, you were right. And why is that? Because no matter what value we're at, if we're at an x of 0, let's see, if we're at an x coordinate of 0, well, we're going to make that 1. And if we're an x coordinate of 0.5, we're going to be 1.5. And if we're an x coordinate of 1.0, we are going to be at 2. But remember, no values matter beyond 1.0. So basically every value that's getting stuffed into the gradient variable is 1.0. So that's not going to be terribly helpful. So if you ever add by more than 1.0, you're kind of going to lose something unless you're in the negative values, in which case you're adding 1 to that. You might see something beneficial there. And we can even look at that. So in a minute. But let's add just a little bit. Instead of all of 1.0, let's add 0.1. And you can kind of see that we sort of shifted away. And now our black is no longer as black. See, if we come and add 0, just have a look, see it's darker. And if we add 0.1, we've kind of gotten rid of our darkest black. And why is that? Well, think about it. Let's come here and just go over this. Like I said, I think sometimes for some people, and if you've already moved on, that's great. But if you're still struggling, sometimes it's helpful to just see the same thing again and again. So UVX, we know over here is 0.0, and all the way over here is 1.0. So you're probably sick of me saying that over and over. But if we come down here to our x value, if our UVX is 0, what is our blue going to be? Well, it's not going to be 0. It's going to be 0.1. And so 0.1, so this pixel right on the edge, which used to be black when it was 0, is now actually just getting a blue value of 0.1. Oop. Let's scratch that out. I think I can actually hit B. Oh yeah, look at that. All right, so the blue value is going to be 0.1, not black, but slightly blue already. And if you can see here, you can already start to see this line here, right here. Oh, let's go back to red so you can actually see what I'm doing. You can, ooh, that was not what I wanted. All right, let's just try. Ooh, what is happening? All right, let's try this again. Oh, my pen is freaking out. This Intuos sometimes has its problems. Does that work? Okay. Right. Has a mind of its own sometimes. So if you can see here, let's try this one last time. You can see that there's a line that sort of separates solid blue from our gradient. And why is that? Well, if you think about it, the minute we hit to 90% of our gradient, right, the minute our x values pass 90%, anything over 90% is going to equal 1. And so what you can kind of see happening is that we've shifted our gradient, right? We're not solid anymore. We've actually moved the gradient this way. So it's not stretched in any way. The gradient is exactly the same size as it was before, but instead of going from the darkest black to the brightest blue and beyond, we've actually just kind of moved this gradient over to the left a little bit. So we're starting out with brighter blues. So I hope that kind of makes sense, because when we start to look at the sine waves, it's going to be very helpful to understand adding things to your values will shift, and multiplying by values will crunch. And I hope that kind of makes sense. Right, so just to show you one last time, gradient UVX times 2. We multiply by bigger values, we stretch. Oop, what happened? Oh my god. All right. 2.0. We've crunched, or and you can even crunch more. Let's see, multiply by 8. Now you've crunched the gradient really small. And if we go by lower values, 0.2, let's say, now you've really stretched, right? You've stretched the gradient all the way over there, and all you're seeing is this left-hand portion of the gradient. Because, again, our UVs stop at 1. And if we add 0.1, you can see we're shifting the gradient to the left. 0.2, for 0.5, we've now shifted the gradient halfway through, so any value. Ooh, what happened here? Oh no, I killed Godot. Let's see, shader fiasco. This is a fiasco indeed. All right. Oh, now I need to set up that power toys, those hot zones, because this is getting annoying. All right. So now, like nothing happened. So now we've shifted the gradient all the way, basically halfway. So halfway, our values, as soon as they hit 0.5, we've now made these 1. So everything this side is a solid color of 1 or beyond, but again, max out at 1. And our 0 is no longer 0, right? Our 0 is already 0.5. Now it's not crunched anymore, but it is stretched. But let's actually do the two together, and we can kind of see what happens. So if we crunch our gradient by multiplying by 2, remember order of operations, so we've crunched our gradient. And now we've also shifted it by half. But let's actually shift it the other direction. Let's subtract, and let's see what happens. Let's subtract by 0.2, and let's see. So now we've kind of crunched our gradient, but we've also shifted it over to the left, and now you can see we've got a lot of black. And if you think about it, basically all of the x, until this gradient, until this uv.x times 2 equals 0.2, as any values less than that will remain black, because we're subtracting away, and anything less than 1 will remain black. So hopefully this is starting to make sense. I mean, we can just kind of take a value. Let's have a look at a UV value of 0.05. If we take our UV coordinate of 0.05, which is basically 5%, so this is 5% along our x-axis, 0.05 times 2 is, if you guess 0.1, you would be correct. And if we subtract away 0.2, we get negative 0.1. And of course, negative 0.1 is black. All right, and so you're not going to start to get out of black until this equals 0.2, right? And so, and just to make this so at 10% of the screen, oh, where's my pointer? There it is. So at 10% of the screen of our gradient, at 10%, 0.1, that's going to equal 2 times 2 is going to be 0.2, and 0.2 is 0. But now any value over that is going to be shifted. I'm sorry, is going to start to be in the positives. But of course, remember our gradient is crunch, so at some point we're going to pass 1.0. In fact, we will at what? Let's say minus 0.2. So we basically need that to be 0.8. So at a UV value of 0.4, right, 40%, this will be 0.8 and 0.8. Oh no, I've lost my mind. Oh my goodness, my math. Gradient plus 2. So where will we hit 1.0? We'll hit 1.0 when it's, when it's 1.2, right? So that's when we're going to hit the line, is whenever this value, so let's get rid of this, whenever this equation, this part of the equation hits 1.2, right? And we subtract away 0.2, we'll finally hit our gradient of 1, or sorry, we'll hit our value of 1 and the gradient will cease. And when will this equal 1.2? Well, it's 0.6, right? So 0.6 times 2 will equal 1.6. So it's 60% of the way, somewhere around here. This will now be the solid white color going forward. So I hope that's kind of making sense. Crunch versus stretch. If you multiply by either higher than 1 or lower than 1, and then shift to the left if you subtract, and shift to the right if you subtract, or shift to the left if you add. So try and get those relations in your mind when we start into the sine function. So without further ado, let us look at what happens when we start to put our UVs into sine function. So we're going to take our gradient, and we're just going to take the sine of it. And it looks not terribly different, right? And if we come to our calculator, we'll see why that is. If we just come here to sine x, we can see that as we go along our UVs to a point of 1, we're actually just kind of increasing it from 0 to a maximum of 0.8. So this is not the brightest blue that it could be. And we could probably see that if we mix in a little bit of, let's make things more complicated. But we can start to see that if we take the UVX, right now we're only in this part of the sine wave that is boring. It's basically just like a normal gradient. But remember, we can start to crunch our function. So, and how do we crunch our function? Well, we multiply by a value. So let's crunch our function by, let's say, 2. Let's see what happens. And now you can see, well, we're getting there. Well, let's kind of come back to our calculator here and let's see where we are. If we multiply our sine by 2, and we come here, well, we still have this problem of our UVX is not passing 0, right? So we're coming here and we're maxing out on the brightest blue, and then we're starting to come down, but this is still pretty bright blue. So even though we're past our UV of, let's see, where will the sine max out? It'll max out at about 0.78 now. So when we hit our UVX of 0.78, we'll have our max bright blue, but as we start to come down, we'll get a little darker blue. And can you see that? It's really hard to see. So let's just multiply by a bigger value. And now we start to see things repeating. So let's see. So let's come back to our handy dandy Windows calculator, and we'll come to 3x. And now let's have a look at what's happening. So now all of a sudden, let's see. Okay, now we can see our 1. Now all of a sudden, when our UVX is 0, we're at 0. When we hit a value of, let's see, about halfway through, right, 0.512, somewhere around there, we're hitting our brightest blue, and now we're going to start to decline again because we've crunched the sine function a little bit. And now we're not actually going to hit, if we look here at our UVX value of 1, so all the way to the right pixels, they aren't actually going to hit perfectly black. They should hit maybe around, what is that, 0.1. So, and here, let's just see. So if we look here, this is our x value along our function, and here's our y value. So this is going to be what our grading, or what our blue color is getting assigned, is going to be getting assigned 0.135. So about 10% blue, but of course 10% blue to our eyes on this computer looks pretty black. So what if we just don't stretch it quite as much? Let's say 2.5. Now you can see it's starting, we can see a little bit more clearly. Here's our blacks starting out, right? Here's our blacks starting out, and we're peaking somewhere around here, and we're starting to come down again on our sine function, and that's why these pixels are starting to get darker. All right, so now we've learned how to kind of crunch it, and let's crunch it a little bit more. Let's see if we can get some nice patterns in here. Let's do 10.0, and you can see, my goodness, we're really starting to see some stripes. 20, and you can see a lot of stripes, right? And what's happening here, we're crunching our sine function, so now little teeny tiny value changes are going to have big changes in the sine wave, and we're coming back down again, and now we're going to spend, remember, we're not making our absolute values, so we're going to spend a lot of time in darkness, and then we're going to start to come back up, and if this is the 0 line, right, if this is y equals 0, ooh, let's not do y, let's do gradient equals. The gradient is going to be 0, and then it's going to be bright blue at, whatever this value of x is. What is that, like about 5%? And we can even just prove that to ourselves by coming back to our Windows calculator one more time. Oh no, I deleted my, but if we make this 20, we can see that just about at 10%, maybe 8% of our way through, we'll hit our first peak. Then we'll spend a lot of time in our valley, and then our second peak should be right around 40% of the screen. And that looks to be about right? This is about 8% of the screen is our next blue, and this is about 40%, and then you'll keep going on from there. All right, so we've kind of done that. Let's take the absolute value so that we're not spending so much of our time in darkness. Absolute value. Absolute value of the crunched function, and now you can see we've now only going to see those black stripes right where those sine waves hit 0, because the minute that it hits negative values, it's going to bump up again. So we can now see that we've sort of created these darker stripes, we created more bright areas and less dark areas. All right, so what happens if we start to add? Remember, adding is going to shift. So let's come back one more time to our handy dandy Windows calculator, and we've got our function. I'm going to kind of stretch this out to show us what's happening within this 1 range, right? 1 to 1, because that's what really matters to us. So we've really crunched it down, but what happens if we start to shift it? And we can shift the sine by actually placing it within the sine function. Remember, if we just add to it, we're just going to move the entire sine function up, right? So now we're just basically moved the sine function up, but that's not going to really help us too much with shaders, because any values above 1, and not to say that you can't use it, and there might be reasons why you want to just kind of see a really fast ramp up and then just a flat kind of top, and then bright area and then a really fast down ramp. If you actually think about it, the more you make these frequencies, the more squared off the slope of the lines increase, the more squared off you're going to start to see these areas being. But let's just come back to 20, or maybe even 15, so we can kind of see a little bit better. And let's get rid of this +1. But what happens if we in our y equals mx plus b, inside our function, what happens if we start to add values. So let's just add just a tiny little value. Did you see? It kind of moved a little bit. And if we go by 2, it moved a little bit more. And let's say we add by 3, and it moved a little bit more. And let's say we add by 5. You can kind of see the whole sine function is starting to shift to the left. Right now, when we were at just 0, when we were adding 0 to it, we saw that the first peak happened at an x value of 0.1, right, about 10%, right? That's where our peak is. Let's just show you that really quickly. So you can see here, here's our x value. I'm going to use my pen, I'll just use my mouse, so this is going to be really awful. When our uv.x value is about 10% of the way across the screen, we're going to have our first bright blue peak. But let's add 0.5 to it. We're going to shift it over, and now we're peaking at around 0.72 or 0.6, somewhere around there, 0.7. See that? About 7% of the screen is going to be our first peak. And let's move this over a little more. Let's maybe even add 1 to it. And hit enter. Now we've moved it even more. Let's even do a little bit more. Let's 1.5. Okay, 1.5 seemed to be the trick. So when we added 1.5, we've actually shifted the sine curve to the left by almost whatever that difference was between 0.8 and now 0. So now when we're at our UVX value of 0, now we're going to hit our first peak. So let's actually see this in our code. So let's just add, so we'd add our UVX times that, and then within our sine function, let's add, what did we add? Oh goodness, 1.5 I think. And now, look at where our peak is. Remember before it was, let's just do 0.0. If we look, our peak was right here, right about 8% or so, right? But if we add 1.5, we've now moved this to we've kind of shifted our sine wave to the left. We're hitting that peak sooner than we otherwise would have. So hopefully, you're kind of catching my drift. Where we're going this is, what if we manipulate this, instead of just adding a constant value, what if we add time? And now, all of a sudden, our sine wave is moving, our peaks are moving. And that's how we're going to, eventually, in our next, we're going to stop here, because I think that was a long time. Hopefully, you're starting to see where we're going with this. And of course, we can make our time value bigger, so it kind of moves faster, right? We can make it maybe multiply by 10. And now we're really moving, right? Because now we're really shifting this sine curve to the left faster and faster as we're making this time value bigger by multiplying it by 10 and then adding this to our sine function. Now, of course, you can crunch it using time too, and we'll see what that looks like. So let's just, instead of adding it, we'll just kind of do this. And of course, that's boring. But let's multiply by time. So now and now you can see, oh my goodness, it's over time, we're increasing the crunchiness of our function. And now probably multiplying by 20 is not going to be what we want. So let's just multiply by time itself. And of course, one of the problems is the time is actually Godot's editor time. So if we hit play, we'll actually start to see this happening over time, because unfortunately the time variable when we're in the editor is actually just going to keep getting bigger and bigger. It's not going to reset until we use it again. But you can see here that it is indeed slowly crunching the values together. We're crunching the sine function over time rather than moving it over time. So, and hey, if you want to do, let's just come back to our thing for a second. Ooh, where are ya? Where's my shader? Oh, there you are. If you wanted to stretch it, you could do 1 over time and see what happens there. Oh. No. Okay. I don't know what I'm doing. Let's, instead of dividing by time, let us just do the multiply by 20 to get back to our usual crunchiness, and let's just and we did time plus time, and we started to shift to the left, and we multiplied by the time by 10, so we made it a little bit faster. So now we can see. But what happens if we subtract time away? We move the gradient the other way. Hopefully this is starting to click a little bit with you, and you can start to do some fun patterns. And this is exactly how we did that when I showed you in the first video, that that kind of shader, red shader moving over. We can just move this gradient from our blue to our red, and now we've got a red variable moving that way. And if we want to move it the other way, we add time. If we want to make it slower, we take our time variable and we multiply it by oh, no, that'll make it faster. Multiply by 2. And now it's slower, but still faster than 1, which is even slower. All right, so I hope that this has been kind of helpful to just to kind of starting you on your journey path of shaders. And of course, you can make a time variable, this whatever we're multiplying it with, as a uniform and adjust it there. So let's, before we finish, let's just do that. Float frequency or speed. Let's just do speed, and we'll do a hint range, and by 0.01, and it'll equal 1.0 to start out with. And instead of multiplying by time by this value, let's make it by speed. And now we have a speed variable. Oh, right, because our speed is stuck at 1s, but let's make the hint variable from 0 to 20 by 0.1. And now, if we start to manipulate the slider, now we're moving faster, moving a lot faster. And of course, you can go past that range. Oh, no, nope, the hint range will lock it, so it'll clamp it. But let's make this hint range 50. And now that you know how to manipulate this with code, is really going. Now that you know how to manipulate these shader parameters by code, you can change it. We can even animate it, assuming that works. But obviously, we were not terribly successful with that the last time. But let's just come back here. We'll set our speed to 0 to start with. We'll just add our animation player. And we'll come here to our rectangle. Oh, we'll make a new animation. And we'll come back to our color rect, and hey, the keys worked again. So we'll set our speed, we'll key it to start with at 0. And then we'll make this animation 5 seconds long. And we'll come over here to 5, and we'll key this value at 50, and we'll make sure our interpolation mode is continuous, not discrete, otherwise it won't interpolate over those values. We can clamp the loop, and we can autoplay it, and now when we start, there it goes. And here, let me block that one so it's not distracting, but you can see here, starting off slow, and it's ramping up over time. And of course, if it goes too fast, your graphics card is probably going to have artifacts and stuff. But all right, let's see. Anything else we can do over time? Well, I think that's enough examples. So, good luck in your Godot adventures.